Well, hello there, everybody. My name is Jason Pasha, and I really don't talk like this. But I am going to be talking to you about a certain topic in evolution that we've already covered a lot. And this topic is genetics. Subject to matter, however, not so much. I'm going to be talking to you about whether homosexuality is caused by genetics or if it is by choice. And there's a lot of controversy about this in society, so I thought it would be okay to do it. First point, many people believe that homosexuality is not of the natural. Whether it be if you're religious, in the Bible, a man and a woman should be together. But it's not also found in natural environments, and that's what most people think. It does make sense if evolution did really occur, and if it is a true theory, then if a man and a woman produce a homosexual, two guys can't have a baby and two women can't make a baby. So natural selection should automatically select against this gene. If you can't reproduce, then what's the point of living? But research does show that animals that exist in natural environments possess homosexuality traits such as mate pairing, sexual behavior, and genital stimulation. Animals such as zebras, penguins, elephants, horses, and chimps all have been identified in this category. And it just happens to be that 98% of the chimp's genome is the exact same as the human genome. So if the chimps have it in their DNA, then most likely we do too. And another point, if homosexuality was in your genome, then wouldn't identical twins be homosexual if one wasn't and one was? Let's take a look and see why this doesn't happen most of the time and what really does happen.
Study sexual orientation. Scientists are currently looking at three main areas: genes, hormones, and birth order. Of course, most of these studies focus only on male sexuality. Sorry, Martha.
What a shock.
Let's first look at studies of identical twins.
Hi.
When one identical twin is a gay man, the other twin is gay up to 70% of the time, far higher than would occur if genes played no role. In fact, these studies show that genes play a greater role in determining sexual orientation than they do in whether or not you're right or left-handed. And we don't punish the left-handed. Well, not anymore.
Let's get it!
Scientists have recently noticed a striking statistical phenomenon. Studies show that having older brothers increases the odds of a boy being homosexual.
Moms always baby the youngest, making them gay.
No, that's not it. When a woman is pregnant with a boy, scientists are realizing that her female body often sees the male fetus as a foreign object and begins to produce antibodies against it. The more boys a woman has, the more adept her body becomes at feminizing the fetus, which may explain why with every successive boy, the odds that he will be gay go up significantly.
All right.
I know it's just a little cartoon, but that information in it was accurate, and it did show of good purpose. But my last point I want to make is I found a research article done by Hammer and his colleagues, and this was done a couple years ago. But and this really was big findings in this category. And what he did, he took about 100 participants that were homosexual, and he did a background research of his family, and on his mother's side and father's side, maternal and paternal. And he did background checks on their aunts, uncles, grandparents, and got their sexual orientation also. And a pedigree analysis is finding traits that are genetically influenced and are passed on from generation to generation. So what he was trying to find was if there was a linkage between homosexuality and his family members and past family members that were passed on from generation to generation. So what he did was, when he looked at, when he did the background check of his family, he did mapping and all these different graphs and to show to lay out what his results were. And what he found was that, here's an example of one right now, just one of his mappings of the pedigree analysis. Black squares represent homosexual males, white squares heterosexual, and white circles are the females. But what he found when he looked closely at it was that if the homosexual participant had a homosexual relative, it was only on the maternal side. There was no on the paternal side. So he figured, what would lead to this? Why is this happening? And he also saw that maternal uncles and sons of maternal aunts were the biggest findings that he had. He found most homosexual relatives were either the maternal uncles or son of maternal aunts. And this is only on the mother's side. He didn't find any father's side that was significant value. So he thought, why is this happening? What is going on? So he did further analysis, and what he did, he looked at the sex-linked chromosome, the X chromosome of one that is inherited by the offspring of a mother and a father, the X-linked chromosome and the Y chromosome. But he looked at the X-linked chromosome in the homosexual participants. So what he did, he took a new sample, 40 pairs of homosexual brothers, 2 brothers that were homosexual. And what he did with this, when he took DNA, he extracted their DNA, got a sample, and he did a PCR, which we learned about in class, just amplified the DNA so he could sequence it. But what he did a DNA linkage analysis on the 40 pairs of homosexual brothers. And he hypothesized that if the X chromosome contains a gene that contains probability of an individual being homosexual, then genetically related gay men, aka the gay brothers, should share X chrome markers close to that gene. If no such gene exists, then there should be no correlation between sexual orientation and the X chromosome. So very, very briefly, he looked at, well, not very briefly, but quickly speaking, when he looked at the X chromosome, he saw one distal region of the chromosome, and this was called the IQ28. He noticed 5 loci, which are just spots on a chromosome, just 5 areas that contain certain genes. It could contain 100 genes, but 5 loci between all the 40 pairs of the 40 pairs of homosexual brothers. And what he found was that when he looked at it, the 5 loci were between the homosexual brothers were almost identical. And so we just labeled it as one locus, which could contain 100 genes. But since they were so closely related, with confidence levels over 99%, I can show you the actual map or the actual sequence he made. It is right here. He labeled the 5 loci as R, S, T, U, and V, and it says Q28. And when the bottom row shows that the confidence levels that he had were over 99%, and they were just in the third row from the right shows how closely related and percentage-wise these 5 loci were 82%. So this was very big for his colleagues. So he basically determined that homosexuality could be one cause of it could be on the X-linked chromosome from the maternal side of the homosexual participants, because what he found was that it was only on the maternal side that if homosexual relatives were related, and if homosexual brothers, they just the homosexual brothers were almost identical on this region of the X chromosome. IQ28 is what he called it. So he determined that one part of homosexuality and sexual orientation may come from this one region in the X-linked chromosome. Hammer and his colleagues' study actually showed up in the media a lot, and here's a clip from a show that used his study for their show.
All right, Mr. Griffin, at this time we're going to inject you with what we believe we've isolated as the gay gene.
I don't understand.
Well, if we're correct, we will have successfully proven that homosexuality is genetic and not a matter of choice or environment.
Are you crazy? I don't want to take a chance on being gay.
We'll give you $125.
All right, I'll do it. Boy, you're more persuasive than James Bond. Hi.
So how'd the medical experiments go?
So good, Lois, so good. I'm gonna squeeze right in here if my thighs will let me.
Peter, what exactly did they inject you with?
Oh, all sorts of things. Hepatitis vaccine, a couple of steroids, the gay gene, calcium, a vitamin B extract.
What did you just say?
The gay gene. I assume that's the one you meant, even though it wasn't literally the last thing I said when you said, "What did you just say?" It's just that clearly it was the most unusual.
Yes, that's the one I meant. Peter, are you gay?
All right, Mr. Griffin.
Thank you for watching. Have a nice break, and I hope I get an A, because I really need the grade, and please give me an A on this, because I worked really hard, and it's 1 o'clock in the morning right now. And, but really, have a nice break, and thank you for watching once again.